Good morning, children. We will continue doing these three numericals which are left in this exercise. Numerical number 13, 14 and 15. Okay. These three are a little different from the other ones. But if you understand it, it will be easier. Okay. Now, 13th question. A car travels with a uniform velocity of 25 meter per second for 5 seconds. The brakes are then applied and the car is uniformly retarded and comes to rest in further 10 seconds. Find the distance which the car travels before the brakes are applied, retardation and distance traveled by the car after applying the brakes. Now, usually in the numericals that you have had so far, either the body will have acceleration or retardation, right? In this, the car has uniform velocity and retardation. Uniform velocity for 5 seconds and then the brakes are applied and the car is uniformly retarded. Okay, so in your solution, like when you do the solution, so you just make it into two columns, in the sense this is for first 5 seconds, okay, and this is for the next 10 seconds. During the first 5 seconds, what kind of motion? Uniform velocity. Uniform velocity. And during the last 10 seconds, what kind of motion? Uniformly retarded or retardation. Okay, so this car undergoes both the type of journey, uniform velocity and retardation. First 5 seconds it went with uniform. What do you mean by uniform velocity? Means constant velocity. Its velocity is 25 meter per second. It means it was going with the same velocity 25 meter per second for 5 seconds. At the end of 5 seconds, the brakes were applied and the velocity started decreasing. From 25, it would have kept coming down and down and down, and finally it came to rest. So for this case, 25 meter per second and its final velocity will be 0. Okay, now you can understand like a timeline. It's like started here, okay, started at 0 seconds and then till 5 seconds it was moving, the car was moving with a constant velocity. So you will not have initial velocity, you will not have final velocity, there is just one velocity. That is the meaning of uniform velocity or constant velocity. Now after 5 seconds, here he is applying the brakes and then the car is slowly retarding. So when he applied the brakes, what was its speed? 25 meter per second. And then for the next 10 seconds, okay, for the next 10 seconds, okay, if I write it continuously, it will be 15, 0, 5 and then 15. So for the next 10 seconds, it's undergoing retardation, and at the end of these 10 seconds, it is coming to 0 velocity. It is coming to 0 velocity. So they have asked you to asked us to calculate the distance traveled, then the retardation, and then the distance traveled before the brakes are applied, then distance traveled after the brakes are applied, and then the retardation. Hope you understood the sum clearly, children. First 5 seconds, uniform velocity. Okay. Last 10 seconds, retardation. Okay, if I have to show it in a timeline, I can show like this, or if you want to show this way, you can show first 5 seconds uniform velocity, last 10 seconds retardation. Now because it is uniform velocity, it will have, it's not initial or final, it just has one velocity. Okay, now what difference does it make? Now generally, to find, so this you have to find, first part is distance before the brakes are applied, in the sense distance traveled in the first 5 seconds. Now usually I told you, if you have to find s, either you have to use the second equation or the third equation, ut plus half at square or v square is equal to u square plus 2as. Okay, but In this case, because the body is moving with uniform velocity, you don't have to use these formulas. You have to use the simple formula, that is velocity is distance upon time. Velocity is distance upon time. So distance will be, we have to find distance, velocity into time, 25 into 5, that is 125 meter. Have you understood? Because it is uniform velocity, I need not use any equations of motion. I just have to use a simple formula that velocity is distance upon time. So distance is velocity into time. Because it just has one velocity, I just have this. Now, we have to find S in this case also. Okay. This third part is distance traveled by the car after applying the brakes. To calculate S in this case, I have to use these two equations, or ut plus half at square v square minus u square is equal to 2as. No, I have to first find retardation. Okay, so u, v and t are there. So I can use first equation. So if it is undergoing acceleration or retardation, then I can use these equations of motion. If it is moving with uniform velocity, there is no need to use equations of motion. So we know v, u and t, we have to find a first. Okay, so v is equal to u plus at. That's our first equation. 0 is equal to 25 plus a into 10. So minus 25 is equal to 10a, or a is equal to minus 25 by 10, or minus 2.5 meter per second square, or retardation is plus 2.5 meter per second square. So your B part, you are asked to find the retardation. Okay, so the answer will be 2.5 meter per second square. And then third, they've asked you to find the distance traveled after the brakes are applied. Now, once you know the retardation, you can use either this equation. Okay, so if we use the second equation, ut plus half at square. U is 25, t is 10 plus half into our a is minus 2.5 into 10 square. Okay, so 25 into 10, 250. Now this will become minus, yeah, 2.5 by 2 into 10 square is 100. 50. Okay, so please leave this separately. Okay, so after this 250 minus 25 5s are 125, 0. Okay, so 250 minus 125, that will be 125 meter. That is your answer. So this is also 125 meter and this is also 125 meter. Hope you have understood, children. So in the same numerical, you have two kinds of motion. First is uniform velocity, second is retardation. So you will have different formulas. Here you'll use the simple formula for velocity is equal to distance upon time. No need to use equations of motion because there is no initial velocity, final velocity. There is just one velocity. So you can use this direct formula. But when it comes to the second part where it is undergoing retardation, you have to use equation of motion because there is an initial velocity and final velocity. So using the first equation, we found acceleration, then we got the retardation, then using the second equation, we found the displacement. Is it clear, children? So this is how 13th has to be done. Now, yeah, we'll continue with the 15th sum now. A train starts from rest and accelerates uniformly at a rate of 2 meters per second square for 10 seconds. It then maintains a constant speed for 200 seconds. The brakes are then applied and the train is uniformly retarded and comes to rest in 50 seconds. Find maximum velocity reached, retardation in the last 50 seconds, total distance traveled, and average velocity of the train. Okay, now if you carefully watch this question, a train starts from rest. So we'll do the timeline first. Okay, so 15th question, a train starts from rest, accelerates uniformly at a rate of 2 meter per second square for 10 seconds. Okay, then it then maintains a constant speed for 200 seconds. The brakes are then applied and then it comes to rest. So this body has all three kinds of motion. First is acceleration, second constant velocity or constant speed or constant velocity, and the third is retardation. Is it clear, children? So in the first 10 seconds, it underwent acceleration. It then maintains a constant speed for 200 seconds. So 200 seconds, it maintained a constant speed. And then brakes are then applied, comes to rest in 50 seconds. So in the next 50 seconds, it had retarded. Okay. So if we do the timeline, okay, and here it was moving with a velocity starts from rest. So it was initially at rest and accelerates uniformly at a rate of 2 meter per second square. So acceleration is 2 meter per second square. Okay, it then maintains a constant velocity, brakes are then applied. Only this much information is given. Okay, now see if we draw the timeline, so the first 10 seconds, it underwent acceleration. It started with 0 meter per second and then reached a final velocity which we don't know, we'll calculate. Then the next 200 seconds, it traveled with a constant velocity. Now, and then the last 50 seconds, it underwent a retardation and then came to rest finally, right? Now, so in the first case, acceleration is going on, so I have to use equations of motion. I can use equation of motion. First, I'll find final velocity. V is equal to u plus at. So my u is 0, a is 2, t is 10. So 20 meter per second square. Okay, sorry, meter per second, this is velocity. So it started with 0 meter per second and it reached 20 meter per second in 10 seconds due to this acceleration of 2 meter per second square. Is it clear? And then the next 200 seconds, it moved with the same velocity. When it was here also, its velocity was 20 meter per second because no acceleration, no retardation. It was moving with a constant speed or constant velocity during this whole 200 seconds. Okay. Then the last 50 seconds, when he was here, he applied the brakes. At the end of 200 seconds, brakes were applied and the train is uniformly retarded. Here it is undergoing retardation, means speed will decrease and finally comes to rest. Now this will become the initial velocity for this journey and its final velocity has to be 0. Have you understood? So we have three kinds of motion. First is acceleration, second is uniform motion, and the third is retardation. Okay, so all the three have to be done separately because formula used and everything will be different for all the three. So three motions you write: acceleration, constant speed, and retardation. Okay, so from this we got the final velocity, that is 20 meter per second. Now with this velocity 20 meter per second, this body will go for 200 seconds. And the B part they've asked you is the retardation in the last 50 seconds. That we'll find later. Total distance travel. So in this case, as I told you in the previous numerical, if it is constant thing, I just have to use the simple formula. Velocity is equal to distance upon time. No need to use the equation of motion. So distance will be V into T, 20 into 200, that is 4000 meter. Okay, so distance traveled during this 200 seconds is 4000 meter. We have to find the total distance traveled, means I have to find distance in all the cases. So let me find distance here. So I can use ut plus half at square. My u is 0 plus half into 2 into 10 square. Okay, so 2 and 2 will get cut. 10 square is 100 meter. Okay, so during the first 10 seconds, it has traveled a distance of 100 meter. During the next 200 seconds, it has traveled a distance of 4000 meter. Now let's come to the third part, that is the retardation. And they've asked us to find the retardation. Okay, so for this part, its initial velocity is 20 meter per second and final velocity is 0. Whatever was the final velocity here, that will become the initial velocity here. Or whatever was the uniform velocity here, that will be the initial velocity here. And its final velocity is 0 because it is undergoing retardation. And in 50 seconds, this happens. And we are asked to find the retardation. So, V is equal to U plus 80, V0, U20, A, we have to find T50. So bring this side, it will become minus 20 is equal to 50 into A, or A is equal to minus 20 by 50 or minus 2 by 5 minus 0.4. Yeah, minus 0.4 meter per second square. But they've asked you to find the retardation. So you will write retardation is plus 0.4 meter per second square. Is it clear, children? And in this case also we have to find distance traveled. Okay, in this case also we have to find distance traveled. Again, I can use any equation. So S is equal to ut plus half at square. U is 20, T is 50 plus half into A is minus 0.4 into okay 0.4 into T square is 50 square. Okay, so 20 into 50 is 2 5s are 10, 1000 minus, okay, so half into 0.4 into 50 square will be 5 square is 25, so 2500. Okay, so if I cut this will be 0.2. So 0.2 into 2500 will be 2 25s are 50. 2 zeros, 1 will go off. Okay, 0.2 into 2500 will be 500. I'll get 5000, then I have to put a decimal here, so this 0 will go off. So 1000 minus 500, it will be 500 meter. Is it clear? So distance traveled. So they've asked you to find the total distance traveled. So what will be the total distance traveled? Is equal to 100 plus 4000 plus 500. That is 4600 meter. They've also asked us to find the average velocity. Average velocity is total distance upon total time. So our total distance is 4600. What will be the total time? 10 plus 200 plus 50. That will be 260 upon 260. Okay. If you divide this, you will get 17.69 meter per second. 17.69 meter per second. Okay, children. So it looks like a very long numerical, but yeah, if you understand it, it will be easy. Okay. So divide it into parts and try to understand it, then it will be easier. Okay, then We're left out with 14th question. A spacecraft is in a straight course of with a velocity 75 kilometer per second, fires a rocket motor for 6 seconds. At the end of this time, its speed is 120 kilometer per second. Okay, this is about a spacecraft. Okay, rocket. It was moving with a velocity 75 kilometer per second initially, and then it was undergoing acceleration. Fires its rocket motors for 5 seconds, means when the rocket is fired, it is undergoing acceleration for how much time? 6 seconds, and its speed is increased to 120 kilometer per second. Have you understood? It started with 75 kilometer per second and it accelerated for 6 seconds and its speed came to 120 kilometer per second. Remember, it's a rocket, so that's why the speed is very high. Okay, then now find the spacecraft's average acceleration while the motors were firing. We have to find the acceleration in this case. So U is 75 kilometer per second, V is 120 kilometer per second, A we have to find, time is 6 seconds. Okay, so V is equal to U plus AT. 75, 120 is equal to 75 plus A into 6. 120 minus 75 is equal to 6 into A. So 25 plus 20, 45 is equal to 6 into A, or A is 45 divided by 6. 6 6 are 36, 6 7s are 42.3 5 kilometer per second square. Okay, because the velocity is in kilometer per second, acceleration will be kilometer per second square. Okay, you have not had this unit anywhere, but this is in case of rocket. You know, they move very fast. Okay, in 1 second they can cover 75 kilometer. That's why you're getting such a different unit. Okay, now A part is over. Right, now we go to the second part. The distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started, the motors having been in action for only 6 seconds. So they're asking you to find the distance traveled in 10 seconds. Okay, in the first 6 seconds the motor was on, means acceleration was going on, and then after that it will be moving with a constant velocity. Okay, it will be moving with this constant velocity 120 kilometer per second for next 4 seconds, because 10 minus 6, 4 seconds. Have you understood, children? Only when the motors are on, it will undergo acceleration. So only first 6 seconds it underwent an acceleration, and then it will maintain the same speed and move. Now you know about rocket launching, no? So when they launch it, okay, when they launch it from Earth's surface, they will launch it, you know, you'll see fire coming out and all that. There will be fuel that is burning that will accelerate this and push it up. And once it is pushed up, this will happen only for few seconds. So that's why it's for 6 seconds this motor was working, and then it has been pushed up, and then it is going to maintain the same velocity. Same, that is the principle here. That's why it is constant velocity. Okay, now we have to find distance traveled again. So in this case we have two kinds of motion. One is acceleration. The first is acceleration, and second one uniform motion or constant velocity. We call it uniform motion. So in case of, so uniform motion is for 4 seconds with the velocity 120 kilometer per second. Now the second part of the question, they've asked you to find the distance traveled by the spacecraft in the whole 10 seconds. Now to find this, you have to use a separate formula for this, separate formula for this, because here it is acceleration and here it is constant velocity. So using this information, you will find the distance traveled for first 6 seconds and then using this information you will find the distance traveled for 4 seconds. So if we take s is equal to ut plus half at square, u is 75 into 6 plus half into 7.5 into 6 square, that is 36. Okay, for this velocity is equal to distance upon time. So distance is equal to velocity into time. So that will be 120 into 4. So 12 fours are 48. Okay, 480 kilometer. And here it will be, when you solve this, you will be getting 585 meter. Okay, kilometer, sorry. Okay, so what is the total distance? Total distance will be 585 plus 480, that will be 1065 kilometer. In 10 seconds, it will travel 1065 kilometer. You can just imagine at what speed it will be going to reach this. Is it clear, children? So these three are little different, in which 2-3 types of motions are combined in the same numerical. Okay, so if you don't understand anything, please pause it, hear it again, then you will understand. Tomorrow in the MCB, I will be giving some homework, 2 sums of homework based on this type. You have to solve that. I want you to solve this also in your notebook. This you can do along with me when I teach, and then the homework once you will be doing it by yourself. Thank you, children.